Welcome to the pre-launch press conference for NASA's Lunar Atmosphere and Dust Environment Explorer, or LADEE. I'm Keith Kohler, News Chief here at NASA's Wallops Flight Facility on Virginia's Eastern Shore. LADEE is scheduled to launch at 11:27 p.m. Eastern Time tomorrow night, September 6, on a U.S. Air Force Minotaur 5 rocket from the Mid-Atlantic Regional Spaceport's Pad 0B. I would like to introduce today's panel members. First, we have John Grunsfeld, Associate Administrator for the Science Mission Directorate at NASA headquarters in Washington, D.C. Next is Pete Worden, Center Director, Ames Research Center, Moffett Field, California. Bill Robel, Facility Director here at NASA Wallops Flight Facility. Butler Hine, LADEE Project Manager, Ames Research Center. And Sarah Daugherty, Test Director here at Wallops. We'll have each of our panel members say a few words, and then we will take questions here in the auditorium and also from those calling in. If you'd like to join in the conversation via social media, you can send your questions to #AskNASA. John, if you would like to begin.
Sure. Well, first of all, I'm thrilled to be here at Wallops, the home of our research aircraft, scientific ballooning, and suborbital rockets, but in particular here for the LADEE launch to help unravel the mysteries of the universe, which is our science mission on its mission to the moon. This is a mission that I'm really excited about. You may have heard me say previously, I love this mission because there's so many great things about it. We've studied the moon extensively since the Apollo astronauts last left over 40 years ago. And when we left the moon, we thought of it as a atmosphereless, ancient surface. And since then, with our Lunar Reconnaissance Orbiter, with the GRAIL spacecraft, with LCROSS, we've discovered that the moon, in a sense, scientifically, is still very much alive. It's still evolving, and in fact has a kind of atmosphere, an exosphere, and we'll hear more about that as we go down. And the LADEE mission is going to give us, whole new vistas on our nearest neighbor, and I'm very excited about that. We've studied, obviously, the surface with astronauts, the interior with GRAIL, extensively photographed the surface with the Lunar Reconnaissance Orbiter, so now we get the exosphere atmosphere. And this is an exciting launch for the Wallops facility as well, and extremely exciting for the Ames Research Center, which Dr. Worden will talk a little more about as the first large, complex spacecraft. But more importantly to me is that it was designed as a modular spacecraft, and I think Pete will probably say something about that. As many of you know, I'm a big advocate for modular spacecraft. I worked a little bit on one called the Hubble Space Telescope, which was designed to be modular, although a one-off for servicing, and I think that's great. The mood here is tremendous. I'm sure there are many, many people who are very nervous. I can say one thing for certain about the LADEE spacecraft, which is, at the tip of the spear, on the rocket, ready to go. LADEE's not nervous at all. It's a spacecraft. But I know there are many nervous people here and very excited, and tomorrow night's going to be a great night for science and for the team members. I just want to identify a few folks in the audience. Our program executive, Joan Salute, Sarah Noble, our program scientist, and Jim Green, our division director for planetary science. They're probably nervous. So with that, I'd like to hand it over to Dr. Worden.
Thank you, John. Well, not being a spacecraft, I'm nervous. Particularly so as this has been a exciting path to here. This, as John mentioned, is the first spacecraft designed, developed, built, integrated, and tested at NASA's Ames Research Center. We're one of 10 centers at NASA. We started out as an aeronautics center, so it's just been the last few years we've gotten into space efforts, but this is our third lunar mission, so the moon is our friend. But I also want to thank the team across NASA that helped make this possible. The Lunar Quest program we report to at Marshall Space Flight Center. Our partner, our biggest partner in this has been the Goddard Space Flight Center and the Wallops Flight Facility that we've worked close together on. And I want to say this is the second lunar mission that we've done with Goddard, so we hope this team is a good one. And we're looking to John. Maybe we'll get some more missions jointly with Goddard. We're pretty excited about it. As mentioned, this is a modular spacecraft. Butler will probably tell you a lot more detail about it, but it is really designed to to try to lower the cost and speed up the ability to put together spacecraft. In the past, we've tried to build modular buses. This is the spacecraft component that supports the mission. But the trouble is, one size never fits all. So the idea that we came up with at Ames about 6 years ago was, why not build it kind of like your desktop computer, where you've got slices that you can put together. If you need more memory, you put a bigger slice there. If you need more propulsion, you put a bigger slice. If you need more science, you put a bigger slice. We think this will give us the capability to do a number of low-cost, rapidly producible space missions. So we're very, very excited about it, and we're looking forward to a great mission. Just the final message, of course, is, as NASA says, with anything going on a long journey, Godspeed, so Godspeed, LADEE. Thank you.
Thanks, Pete. Well, so as most of you probably have noticed, it's a pretty exciting and very busy time here at Wallops Flight Facility. You hear the aircraft overhead, so there's a lot going on the aircraft side of things. We've got 2 Global Hawks here that NASA owns and operates that are flying the Hurricane Severe Storm Sentinel mission. We've got a C-130 that we're preparing to go to Greenland for a mission up there. We've got our scientific balloon field out in New Mexico preparing for Comet ISON mission coming up. And then Antares in less than 2 weeks. So hopefully we'll see a number of you back here for that. And obviously the reason we're here today is for LADEE. A lot going on, final preparations nearly complete. You know, after the 3,000-mile trip from Ames here to Wallops, they arrived kind of in the early June time frame. There's been you know, a number of tests that have been performed, and our job working with Ames has been to try to get it ready for the next 250 or so thousand miles, that next big step. And so we're all kind of looking forward to that. Since arriving, obviously the spacecraft has done a number of tests. We've gotten the propellant loaded at our V-55 facility down on the island, and then it underwent some spin balancing to get it ready. It's basically then the vehicle was assembled by Orbital Sciences and the Air Force. The payload was stacked, I think, about the 24th of August, and it's been sitting there since. And I echo Pete's, I'm nervous too, like a lot of us are. It just kind of goes with the industry. And I did want to at least show you one slide. So if I could have the one slide on the launch vehicle, please. And this one was taken yesterday morning, so it shows the Minotaur 5 vehicle on the pad, buttoned up, ready to go. I did see some technicians out there working on some closeout items here a little while ago on the closed circuit television. And a little bit about the Minotaur 5. It's you know, basically a decommissioned Peacekeeper missile that has been recommissioned for doing small payloads and to orbit, or obviously in this case, to the moon for LADEE. Yesterday, we completed our range readiness review, and I'm still happy to report that we're not tracking any major items, so I think that that's good news. It's been a real pleasure for us to kind of work across the agency with Ames, Goddard Space Flight Center, that we're obviously a part of, the Kennedy Space Center folks at the Launch Services Program, and obviously headquarters here. The teams are working great together. It's also been you know, a pleasure to collaborate again with Mid-Atlantic Regional Spaceport, the U.S. Air Force on the launch vehicle, and Orbital Sciences. And I'd be remiss if I didn't introduce Lou Amorosi with Orbital Sciences and Colonel Gillespie in the back with SMC. Also, teams are again working great, and I'm confident we're going to have a good showing here tomorrow evening. And so, as you've heard, LADEE's got a number of firsts. For us, it's the first mission that's lunar out of the Wallops Flight Facility. And I don't know whose idea it was to come up with the moon pies, but it was kind of neat. And so for folks that have seen those or are participating in that, it's pretty neat. First Minotaur 5, so that's also a big first. And then, as you'll hear more about, first test of high data rate laser communications. And so with that, I'd like to pass it over to Butler Hine, and thank you all very much for coming.
Thanks, Bill. So as John and Pete mentioned, this is a modular spacecraft bus. This actually was an idea that we had a while back about how to drive down the costs of developing spacecraft. And if you bring up my first slide, you can see the modules. This is kind of a blow-up view of the LADEE spacecraft. You can see the modules separated. There's a couple of key features of this spacecraft bus. One is it doesn't have deployed wings for solar panels. That's a very nice way to get a lot of power, but it makes your design fairly complicated. It makes your ability to keep the spacecraft safe, more complicated. So one of the things you'll notice in this is these modules, when you put them together, they have solar arrays all around the body of the spacecraft. This means that it can face pretty much any orientation and generate power. So that means it's inherently safe. The other thing is you'll notice that we've clustered things together in different ways. The top module has all of the active electronics in it that are the brains of the spacecraft and the communications of the spacecraft. So that top module can actually fly by itself in some designs. When we're carrying science payloads, obviously we have the payload module. That's where the two main payloads are positioned on either side for balance. And then that third module is stretchable. It can be a single or a double. This, in LADEE's case, it's a double height. And it contains the propulsion system inside it. You can adjust the propulsion system to the type of mission. So this modular bus was designed for a variety of missions, which is unusual at NASA. Normally you say where you're going, you say the science you're going to do, the science defines the instruments you're going to carry, and then that defines how you design the spacecraft bus. In this case, we designed a bus for multi-purpose. So it can do lunar orbit missions, lunar landing missions. It can do asteroid rendezvous missions. It can do Lagrange missions, a whole variety of missions that aren't too far away because it is solar powered. And we're really excited that LADEE, the first attempt to use this bus is going to be around the moon in a low orbit around the moon. We're carrying 4 instruments on board. There's 3 science instruments. There's a neutral mass spectrometer and an ultraviolet visible spectrometer. And then there's an in situ dust detector. The neutral mass spectrometer is built by NASA Goddard. The ultraviolet visible spectrometer is built by NASA Ames. And then the lunar dust experiment, the dust detector, is built by University of Colorado LASP. We're also carrying a 4th instrument that's a technology demonstration. It's a laser communications demonstration. This is a very important technology, has a lot of promise in the future. Right now, most of our missions, or all of our missions, use radio frequency to communicate to the ground. But optical communications can transmit a whole lot more information. In this case, it's around 622 megabits per second back from the moon. So you can think of it as a fiber optic line that forms the trunk lines around the U.S. For internet traffic. So that's what we're trying to demonstrate in this technology. If you go to the next slide, you can see what the LADEE spacecraft looks. It's in the fairing right now at the top of the nose cone of the rocket right now, so you can't see it. But this is what it looks like before we buttoned it up. Although John says spacecraft don't worry, the way we've set up the spacecraft, it actually emails us. It emails us. I've just got an email from it a few minutes ago, and it tells us how it's doing. So think of it like you've sent your kids off to summer camp, and they send you a letter saying they're doing great, but you still worry about them. So that's what the spacecraft's doing right now. It's telling us it's doing great, and we're the ones worrying about it on the ground. So if you play the animation, I can explain how we're going to get to the moon. When we launch out of Wallops, we don't go into Earth orbit. We go directly into a translunar injection orbit, and we do 3 2.5 or so eccentric orbits around the Earth. And every orbit around the Earth, we boost our distance higher and higher until finally on that 3rd pass, we're up around where the moon is. The moon sweeps around it and grabs us. Its gravity field grabs us, whips us around behind it. And then as soon as we come out from behind the moon, we do a big burn with that main engine you see at the bottom. That big burn is what captures us around the moon. If we don't do that burn, we sail off into the Earth-Moon system, and we don't capture around the moon. So that's an important event for us. Once we capture around the moon, we spend about 40 days in what's called a commissioning orbit. It's about 250 kilometers And it's high enough where we don't have to spend fuel to maintain it, but that's where we check out the science instruments. That's where the laser comm does its primary experiment. Once everything's done at that point, we drop down into a very low orbit. The orbit varies from 20 to 60 kilometers above the lunar surface, so it's very low. The moon has a very lumpy gravity field, so when you're flying that low, you're burning fuel just to keep yourself from crashing into the moon. And that's where we do our primary science. At the end of the mission, we don't try to boost back up. We use every drop of fuel to do the science observations, and then after about 100 days, we terminate the mission by intentionally crashing into the lunar surface. So that's the mission in a nutshell, and we're very excited about it. The team's been working hard for a number of years to prove out this design and build this spacecraft and do this science, and we're eager to give it a shot. And the weather looks great. Speaking of that, let Sarah talk about range operations and some of the weather we're looking at.
Thanks, Butler. I'll go ahead and kick it off from where he kind of started, and I'll bring it all the way back down to Earth before we actually get to the moon. So if you'll play my first animation here, you can see, imagine ourselves here tomorrow night, sitting here at the pad. We're on a Minotaur 5 rocket. The LADEE spacecraft is on top of it. We're at the Mid-Atlantic Regional Spaceport, Pad 0B, right here at NASA Wallops Flight Facility. So the rocket takes off, liftoff. It travels vertically for just several seconds, and then it pitches over and heads downrange. And you can see here that our Wallops tracking antennas, telemetry and radar are picking up the vehicle track right off of the pad. And then we also have some downrange sites in Coquina, North Carolina, that also pick up track just a few seconds after liftoff. Here you're seeing the first stage event happen, stage 1 separation, and stage 2 start to burn. In a few moments, you'll see our Bermuda ground station pick up the track as well. The range team has spent a lot of time over the past several weeks testing all of these systems here at Wallops and Bermuda and Coquina, getting ready for the launch. So we've done system checkouts and practice countdowns and rehearsals to get those assets ready for launch. So they're all tested and configured and ready to go tomorrow. Here we just had fairing separation, and we're progressing downrange here out over the Atlantic Ocean. So stage 3, burnout, and now the TDRS, which is the Tracking and Data Relay Satellite Systems, picked up link. That system will help us communicate with the spacecraft once our ground-based systems can no longer see the launch vehicle or the spacecraft. Now the final 2 stages here, 4th stage and 5th stage, will burn and separate. Right now we're at an altitude of approximately 250 kilometers above Earth's surface. Stage 5 spins up here to get the spacecraft spinning for stabilization. In the background, you see we're now at the leg of flight that's actually slightly over the tip of Africa. And now stage 5 is burned out, and we'll see the D-spin happen here to slow the spacecraft down. And the next event will be payload separation and then orbit insertion for us. So, and then where Butler showed you his animation, we'll head onto the moon from there. Just want to touch on the weather for tomorrow, talking about launch operations. So our launch weather officer has predicted a wonderful forecast for us at T0. Looking like mostly clear skies. Visibility is going to be great. There's a slight chance of clouds, but overall is a 95% chance of good launch weather at T0 tomorrow evening. So all systems are go and the weather is looking good. So hopeful for a great launch tomorrow night.
Okay, thank you, Sarah. We'll now take questions. We'll start here first from the audience. If you can raise your hand, we will get a mic to you. And if you could state your name, affiliation, and of course who on the panel you would like to answer your question.
Hey, thanks, Keith. Stephen Clark with Spaceflight Now. A couple of questions. First of all, could one of you go over what's going on at the launch pad right now, some of the activities overnight, and what will be happening during the countdown tomorrow when it begins, and some of the activities leading up to T0. Also, for General Warden, a question about the modular bus. Are there any other missions out there that are planning to use this bus? Are they approved? Are they in the proposal process? And what sort of destinations could this bus support? Thanks a lot.
So out at the pad today, they're doing final arming operations. So there's a lot of explosive ordnance on both the rocket and on the spacecraft, and they're designed to enable certain functions or disable certain functions, and they're usually involved with the safety systems. So what you do to handle the ordnance safely is you put inhibits in there that prevent the ordnance from ever going off while you're working on the rocket or while you're working on the spacecraft. But right before launch, at L-1 day, which is today, you remove those inhibits and you actually arm the vehicle. So that's what the teams have been doing today. The spacecraft team has been arming the spacecraft ordnance, and then the launch vehicle team from Orbital has been arming the launch vehicle ordnance. That's the main activity for today, and it's a touchy activity, so you want to take your time, do it right. And then L-0 tomorrow, we really don't have any key activities. We're prepping things, but it's not hands on the vehicle. There's not a lot of hands on the vehicle at the day of launch.
Yeah, I can answer the questions about future for the modular bus. Of course, until this is proven, which is hopefully tomorrow, it's not likely we're going to get another mission assigned. However, we are in discussions with several offices at NASA headquarters, the Science Mission Directorate, the Human Exploration Mission Directorate, and the Technology Mission Directorate about potential future missions later this decade. As Butler noted, this architecture is ideal for the inner solar system. As we look at potential asteroid missions, as we look at more lunar missions, as we look at Mars missions and potentially to the moons of Mars, as well as science missions in Earth orbit, this is a very interesting concept. I might also add that, of course, it's NASA's purpose that future missions would not be constructed in-house, that we would transition this technology to the private sector. We've been in discussion with a number of different groups to pick up this technology. So we hope it'll enable a new era of lower cost, more flexible spacecraft. And indeed, several of the Google Lunar X Prize teams have been in discussion with us, and we have transitioned some of the data to them. So I think you can look to see a lot of possibilities in the next decade for this approach.
Okay, thank you. Before we go to our next question, we do want to mention that this launch is going to be highly visible if we have clear skies up and down the East Coast. We expect that it will be visible from the Carolinas all the way up into Maine and also west to Pittsburgh and West Virginia. If you go to the Orbital website at www.orbital.com and then click on the mission update and the graphic that we have on the screen, you'll see that. Plus, they also have various graphics there, cartoons that will show you what to be looking for. So this is going to be a really great show for the entire East Coast. Okay, now we can go to our next question. Yes.
Okay, hi, Ken Kramer for Universe Today. Two questions. One, maybe John or Bill, you can answer this. Do you foresee any future for other science or planetary missions launching here from Wallops? And I'd also like to know if someone could talk about a little bit more the conversion work done to convert the Peacekeeper into the Minotaur 5. Thanks.
Well, I'll just once again say that we launch about 20 science missions a year from Wallops. They're suborbital missions, but they're still significant. And when we launch the Antares mission, that mission will be carrying science up to the International Space Station. And so that's an orbital mission. I think, this is a pathfinder, when I don't know if we have anything on the manifest at the moment, but I'm sure, Wallops has a bright future.
So from my perspective, I'd say I hope so. And so, I mean, we'd look forward to it. I think with the capabilities that are put in here now, we've got something to show for it, and especially if we have a good showing here tomorrow night. Relative to your question on the launch vehicle, I mean, Luke can correct me if I miss anything, but it's basically the basic motor set from the Peacekeeper for stages 1, 2, and 3. 4 and 5 are commercial assets that Orbital has used a number of times or are available elsewhere. The electronics are all different than what the Peacekeeper flies. A lot of the staging events, and obviously the fairing would be a big departure. I don't know if there's anything else you wanted to add there, Lou. Those seem to like the big systems.
Okay. Do we have another question here in the auditorium? If not, do we have any questions on the social media?
Hi, good morning. Oh, sorry. I'm Constance. I'm here with the NASA Social Group. Earlier this morning, you guys told us about some of the various systems on the LADEE, specifically the Starfield navigation system. Would one of you please go a little more in depth as to how that is going to help LADEE navigate itself around the lunar orbit?
Sure, I can answer that. What you're referring to are star trackers. They're instruments that are basically specialized cameras, and they are designed to look at the night sky when you're flying and precisely recognize star fields and then precisely tell you what orientation you are in space. It's very similar to how ancient mariners used to navigate the oceans. They would look at the stars and navigate by the stars. So we do use star trackers to basically determine the attitude of the spacecraft. So it doesn't tell you where you are in space, but it tells you what rotation you are, which is very important. And then the where you are in space comes from radio ranging. So we range radio signals from the spacecraft that tell us precisely how far away it is. But the attitude is done by star trackers mainly. It's the most precise attitude source we have.
Next question, either social or media, either one.
Hello, I'm Teresa from the Cape Gazette, Lewis, Delaware. I was wondering, with the evolution of the commercial aspect of spaceflight, how do you think that will affect, especially this immediate area, the peninsula? Can you give some thoughts about that?
I mean, generally, it's been a big improvement since Mars helped us back in the 90s to basically set up the spaceport. So that kind of gave some basic infrastructure. With what's gone on with Antares more recently with the development of Pad 0A, also the investments made by the federal government, the state governments, and Orbital Sciences have all kind of contributed to try to stand up a pretty decent infrastructure here. So I'd have to say it looks pretty good, providing the missions continue to come. I mean, the good thing right now was with space station resupply, I'd say that the future looks pretty bright.
Okay. Next question. Okay, seeing no further questions, that concludes today's pre-launch news conference. A LADEE science briefing will begin at 4 p.m., also here in the auditorium on NASA TV. Live coverage of the launch will begin on NASA TV at 9:30 p.m. tomorrow night. You can also follow the coverage on social media, Facebook, Twitter, and the like. Finally, you can get more information on LADEE at www.nasa.gov/LADEE. Thank you for attending.